Okay. Before we go into next topic, I would like to say something more about the ROC curve and the false confusion metric things. Okay. Here is the view graph from Wikipedia. Okay, if you take a look at the ROC curve on Wikipedia, okay, one of the figures looks like this. Okay, here, let's take a look at this. Okay, usually we have certain features that can help us to, for example, x1. Okay, and here we have a very simple model, which is just a line. Okay, for example, this point is xa. Okay, so this model is very simple. Okay, say if x1 larger than xa, then we say it is y equals to 1. Okay, at the right hand side y is plus 1, left hand side y is minus 1. Okay, we have a very simple classification, and this rule is really simple. Just a number of depending on is larger than xa or larger than x, smaller than xa. Okay, and on the feature x1. Okay, it's quite well. So of course you can have several different parameters, right? So basically, okay, you can easily create another model. For example, let's take the green one. You can simply use another model like this. Model 2. Okay, that is model 1. Okay. However, as we can see, okay, there are different set of data, okay, which is on the one side is y equals to plus 1, which is right here, y equals to minus 1 is right here. However, this part, there's some data which is overlapped. Okay, some of the data, okay, the label is marked as y equals minus 1. However, their x y equals minus 1. However, their x1 value right here is larger than xa or even larger than xb. 好，中文上来说就是说，这样两份资料嘛，一个是 y 是正一的，一个 y 是负一的。那我们用 x1 这个 feature 来去评估它的时候，你就随便切一刀嘛，一刀两断嘛，哈。可是问题是你切在哪里都不太好，为什么？因为这个资料是 overlap 的，而生活中的资料也通常都是 overlap 啊，也就是说呢，你可以找到有一个 y 是负一那一边的东西，可是它 x1 的值啊很大，大到超过 a 跟 b 了，对吧？会 overlap 嘛？而且有的时候你可以找到 y 是正一 ，y 是 label 成正一的时候啊，它的 x1 的值啊，已经小于 b， 甚至小于 a 了，哦，就在左侧了。可是由于你的 model 太简单了，你只能一刀切，那你到底要切在这里面的哪里呢？就是一个很困难的问题了啊。也就是说呢，同样是一个 model， 是因为参数的不同，所以导致于说你可以在这边做调控。那通常而言呢，以这个例子来说了以这个例子来说，那一刀要切在哪里呢？当然就切在正中间这里，对不对？切在正中间这里，它刚好会涵盖到它的右侧都是 y 是1的，涵盖左侧都是0的。那下面怎么办？下面这个三角形怎么办？它就是全部都是错的。怎么错？就是说是1的，但是是负1的嘛；说是负1，但是是1嘛，就是错的。So this is a very simple explanation of false positive, false negative. If we remove all of these things, okay, just take a look at the view graph, okay, and we can see that the blue part is true negative, right? It's true negative because y minus 1, y plus 1 is true negative, right? Because there are some data points they are originally labeled as minus 1, and your model, which is this black line, says, okay, this is less than a certain value, for example, a. So the blue parts are all correct, true, negative. On the contrary, at the right hand side, the red parts, okay, all those red parts are data points that labeled as y equals +1, and your model, which is the black line, says, okay, they are all larger than a, x1 larger than a, so they are true positive. Okay, so here's the true positive. Here's the true positive. Right. However, if your model is very simple, like this one, just a line, just a number, okay, cut this data point, these data points into two parts. There should be false positive and false negative, which is marked as these two area. Okay, these two area. Okay, so if you move your model, okay, along with x1, that means you can move your points. So let's draw it this way, okay? So at certain point, you will have a false positive rate right here, and false true positive rate right here. If you move your model to the right hand side, what is that means? That means your true negative rate increase and your true positive rate decrease， 对。当如果你把你的那个黑色那条线，然后一刀切两半的线往右移的话，那你想你红色的面积一定变小嘛？那可是你红色面积变小的时候，你蓝色面积就变大了。红色面积变小，意思是说是正一，那你判断是正一的量；是蓝色的面积的话，是它原本是-1，但是你判断是-1的量嘛。这完全就 trade off， 因为资料是交叠的嘛。这理由完全就是因为资料是交叠的。所以如果你把你的线往右移的话，你红色就会变小，对不对？可是你蓝色会变大，这怎么办？那个线应该是从这紫色点往左下角才移啊，对不对？因为你的 true positive 变小了嘛，可是你的 true negative 变大了。你的 true negative 变大，就是你的 false positive 变小的。Okay? So if you move your model line, which is from A to the right hand side, and at the ROC curve, okay, your data point goes to the left bottom direction. Okay, if you move your model to the left hand side, which means you increase your true positive, but you decrease your true negative rate, and then you increase your true positive rate, so your model goes this way, which is in green color. So it really depends on your application. Usually, as I say, usually we select the data point which touch the diagonal line. Usually we select it, we view it as a trade-off. Okay, we have a very nice true positive, we have a very nice true negative, and also we have false positive and false negative. But for some application, as we mentioned before, okay, as cancer detection, okay. For example, y+1 means has cancer. Okay, the left hand side -1 has no cancer. So for such kind of application, you want a high true positive or you want to have a high true negative. 就是说，在不同的 application 里面，其实你不是只是选一个中间的 trade off 的点而已，你要看你的 application。像我们那个之前讲的癌症这个例子啊，你当然是希望什么？我说那是比较惊险哈，你当然是希望你被model 判断成有 癌症，但是实际上你没有癌症。我再讲一遍哦，你希望的是你被 model 判断成有癌症，但实际上你没有，因为你可以做很多次的检查，对不对？我们讲这个 model 只做一次检查，你可以做很多次不同的检查，让你的 true positive 变很高。就你有癌症，你一定要知道，你不可以不知道。所以你通常会把这条线往左移一点，你让红色的区块变大，对吧？然后左边蓝色区块不是变小吗？可是蓝色区块变小的时候，就意思是说，有时候你没有癌症，可是你被误判为有癌症嘛，对不对？因为你那个 false positive 区域就变大啦。可是没关系，你可以做第2次检验，做第3次检验，做第4次检验。但是有一些 application 就是那个红色那个区块要越大越好，越大越好。你有癌症就一定要被检查，你不能够漏判。你可以误判，可是你不能漏判，这个是医学上的要求。所以这个时候你就会把线越往左边调越好，你宁愿牺牲 false negative true negative， 可以吗？啊，要记得哈，这个不是一定的哈。啊，这个往左往右就会对应到下面那个豪西克鲁往右上比较右上一点，还是往比较左下一点，这完全是。所以有的时候你做一些商院的，比如说财经的资料啊、医学的资料，很明显就是你不能够做错的。比如说，你判断一个人有没有癌症，你不能做错嘛。你判断一个人会不会不缴钱违约，信用卡会违约，你最好都不要做错。你宁愿是把你说误杀好人，误杀好人你可以复查、复查再复查，对不对？啊，就是要记得哈，会有这些 application。Okay, I think that's okay. We can continue to our next topic. Okay, our next topic will be unsupervised learning. Okay, unsupervised learning. Okay, let's take a look at what is unsupervised learning. As we mentioned before, all the algorithm we told you is under the category of supervised learning, which means we have several features and would like to learn the relationship between those features and your target, no matter it's numeric or category. So what is unsupervised learning? So unsupervised learning. Okay, unsupervised learning means I would like to create a model. Of course, the model is used to describe the data. So we still have data, and for each data, we still have a lot of features to describe those data points. However, we don't have a target. We don't have a specific target when we deal with unsupervised learning problem. So basically, they look simply look like this. There has no target. There's no specific target to describe those data. So when we face such kind of things, what analysis we can do? First, since it is a data point right here, right, the red one, and there is another data point which is the green one. So for unsupervised learning, there are several problems can be analyzed. First, how close? We can write it in a more professional way. Distance between data point. That means given two data points, how close they are, how far away they are. What is the distance between data point 1 and data point 2? Usually, okay, we can draw it in this 2D surface, right? For example, we simply just use x1, x2, and s2. And here is your data point 1, and here is your data point 2. So basically, it has it's okay. And usually we can draw a lot of data points on this surface, right? And basically, the first question we would like to ask is what is the difference? What is the distance between each data point? There are several different ways, okay? So basically, the most straightforward things. The distance is right here, right? So how do we calculate the distance? AB, right? B2 is CD. A minus C. Distance between P1 and P2 equals AC. That is called Euclidean distance， 欧几里得距离嘛，就是非常简单哦，这个没有什么特别，就是欧几里得距离。So basically, when you try to analyze the data without any target, the first things you come up is what is the distance between each data point? Okay. And usually, of course, there are several different, several distance functions, which I will show you later. However, Euclidean distance is the basic one. Okay, if we go back to our website, okay, here is a slide called Distance Function, Scale, and Similarity, okay, and you may take a look at this slide. This one. Okay, and then simply just go to the distance part, okay, which is page 21. So basically, if we don't have any target, so there are just a lot of data points in a multi-dimensional space. The first thing we think about is the distance. So there are several distance, Euclidean distance as we mentioned before, okay? You simply just do the calculation, okay? There are several other distances like this one, Manhattan distance, 曼哈顿距离. Manhattan distance is simply just simply just like this. That is the distance of P1 and P2. If you Manhattan distance， 曼哈顿距离就不用什么开平方或者什么平方之类的嘛，它就是把 x 跟 x 的的差值还有 y， 就是另外一个 dimension y 跟 y 的差值，把它加起来就好了，这就是曼哈顿距离。那欧几里得距离就是我们用那个嘛，那个勾股弦定理嘛，然后就把它平方，然后再开根号这样子。Okay, of course, there are several other concepts called similarity. Okay, the distance means if two data points, their distance value is larger, which means they are far away, right? However, similarity means if the value of similarity of two data points are smaller, which means they do not similar to each other. 这是反过来嘛，相似度跟距离是一个相反概念嘛，对不对？你距离越大，表示你们两个离越远嘛。可是相似度不是啊，相似度是你们相似度的值越高，你们就离越近啊，这个可以理解啊。So usually we have okay, I say usually 1 minus similarity equals to distance. Sometimes we say this. If the similarity, if you have a function called similarity function, or if you have a distance function, and this function will output the distance and output the similarity between two data points, and the value is between 0 to 1. Okay? If both these similarity functions and the distance function, they output the similarity value and the distance value, okay, are all between 0 and 1. And usually, okay, we think this equation is correct. 就是通常我们会说啦，就是我们会设计距离公式嘛，或者我们会设计similarity 就是相似度的公式嘛。那我们通常会把它定在0到1之间啊。所以距离0的意思就是你们两个根本就没有距离，是一样的。距离1的意思就是说你是我们这个空间体系里面两个天差地远的点，所以在距离是1啊。如果我们压缩到0跟1之间的话，那 similarity 也是反过来哈。similarity 就是如果我们两个 similarity 的值是1的话，就是我们两个根本就是一模一样的，在这个空间里面。我们的 similarity 是0的话，就是我们俩没有任何相似的成分存在，在这个空间里面我们俩就是相和超远的点。那基本上，如果你是这样定义的，然后你的距离公式都会输出0跟1 ，similarity 会输出0跟1的话，那这个1减距离就是 distance，1减 similarity 的值就是 distance， 或者1减 distance 的值就是 similarity， 这个就是也不是说常识啊，就是一般来说我们会这样子认为的，好吗？ Of course, there are several other distances. We will discuss those distance or similarity very later. Okay, in different algorithms. Okay, so usually we can draw a similarity or draw a distance matrix. So that is data point, data point 1, data point F, data point P. Okay, so you can draw a two-dimension P1, P2, P3, P4, Pn. We have n points, right? P1, P2, Pn. If we have n data points, we can draw a similarity matrix or a distance matrix. Okay, and usually the design of similarity function or distance function, we say that distance matrix. Okay, at the diagonal line, 就是在对角线的地方 ，okay? Because this cell means what is the distance between P1 and P1? And in our definition, there are this P1 and P1 are identical points. So the distance between these two identical points is 0. So in a diagonal line, there should be all zeros if you draw a distance matrix. And this matrix is symmetric, 就是它是对称的嘛 right? At this data point, at this cell, that means what is the distance between P1 and P2? And right here is the same. What is the distance between P1 and P2? And usually, when we design distance function, okay, the distance function should be symmetric as well. 就是我们设计那个距离公式的时候，我们也会把它设计成是对称的，就是 P1 到 P2 的距离应该是跟 P2 到 P1 距离要是一模一样的哈。因为有时候你会看到一些很莫名其妙的距离公式，是 A 到 B 的距离跟 B 到 A 的距离是不一样的。好，那这样就你在画这个 distance matrix 的时候就要特别小心。好，但是我们通常都会说这个是对称的嘛，哈，所以它这个对角线是0，然后上半三角形跟下半三角形都是一个对称的distance matrix， 好吗？当然是这个样子的。Okay, that is one of the before we start to discuss the unsupervised learning. Okay, we have to say something about distance function. Okay, the very first unsupervised learning algorithm we like to share with you is clustering, which is UPGMA. Okay. UPGMA is so you may take a look at this UPGMA walkthrough. Okay, it is a slide. and I will show you. It's right here. It's right here. Okay. Okay. This one, this slide. Okay. UVGMA, it has a very long name. Unweighted pair group method with a magic mean. Okay. Just ignore it. Okay. Let's just Google. Okay. Let's take a look at Google. We Google something like dangergram. And take a look at this one. 家族数 polygon。家族数是什么 ？polygon。啊，那 family tree，OK。family tree。Okay, that's great. You can simply just take a just Google, okay, family tree or Python, something like that. You can see that there are a lot of different trees. Okay, something like this one. Something like this one. Okay, the resolution is not good, but I think that's good enough to explain it. Okay. If I have a set of data points, okay, what is the first things I would like to do if I would like to analyze those data points? If those data points has a huge amount of data points, for example, 1 million data points, and from my opinion, we do not inspect those points one by one because you have 1 million data points. So the best things you can do at the first place is to try to cluster them, which means if there are some points they are similar, then we group those similar points into one cluster, and we would like to build the relationship between those clusters, just like the family tree, which I show right here. We have a lot of different animals, right, on the earth, but we cannot analyze all those animals. So the first thing is, if I have 1 million different animals, so if I can find certain way to cluster similar animals into a cluster, and then if I can find a way to analyze the relationship between those clusters, and then I don't have to study all 1 million animals, right? So if there are only 10 clusters that can represent all those 1 million animals, then the only thing I have to do is to study those 10 clusters, which is good enough for me at the first place, right? So the first thing is, how do I create a method, okay, to find a method to cluster similar animals into one cluster? So that is how this algorithm does. That is why we introduced this algorithm, which is UPGMA. It falls into cluster algorithm, which is supervised learning, unsupervised learning, because it has no target. Okay, but when we Okay, let's just take a look at this one. Okay, take a look at this table. Okay, we have A, B, C, D, E, F, G. Okay, we have 7 data, A to G, and of course it has several features, something like x1 to xm, which I don't know. But by using the distance function, which, for example, you use a Euclidean distance function, I can create a distance matrix like this one. So this is the distance matrix, the original distance. The distance matrix which I made. As I mentioned before, okay, you make a distance matrix, the diagonal should be O0 because the distance between AA, BB, CC, DD, E and E, F and F, and G and G should be O0. And it should be symmetric matrix, right? Because the distance between A and B is the same as the distance between B and A. So it should be 19 right here because it should be symmetric. But it's okay, we only use half of this matrix to run the UPGMA, which is a clustering algorithm. Okay, let's step by step. Okay, follow my step. Okay, the first things, since we have the distance matrix of these 7 different data points, and would like to cluster the similar data points. So the first step is you find the smallest, the closest distance in this matrix, which shows right here is B and F, right? Because among this distance matrix, 1.00 is the smallest distance, right? That means in certain space, B and F are quite close, right? So what is the UPGMA does? Okay, then you simply use the green color. Okay, you simply just write B and F right here, and because they are close enough, so they cluster at the first run, and you write 0.5, 0.5, and you connect B and F right here. So the height right here is 0.5. Okay, so that is the first step because they are the closest pair. Okay, so the second step is right here. Okay, we would like to rewrite the distance matrix. So basically, we remove the B column and F column, and you remove the B rows, the B row and F row. Okay, because these 2 points already combined it together, and you have to create a new row and a new column, which you just simply write BF. Okay, I simply just write it. The next step is, okay, you have to fill out all this value because you create a new column, right? BF. All the value in this column is empty. Okay, at the first place is empty. So BF column and BF row, all those values are empty. Okay, so how do we fill this cell? Okay, take a look at this one. Take a look at this one. The distance between A and BF. Okay, between A and BF. How do we find the value? Okay, to fill in this cell. Okay, then we think about the original cell. Originally, the distance between A and B is 19. Between A and F is 18. So if we combine B and F to a small cluster, and the distance between A and this small cluster BF should be the average of AB and AF. So 19 and 18, so on the average, the distance is 18, 50. 好，中文再讲一遍哦。我们把 B 跟 F 的两列全部都把它删掉，然后创造一个新的栏跟列叫 BF， 因为我们认为 BF 已经够小了，它们必须被 cluster 在一起，所以它这个新的点，这个新的点就叫 BF。那我们怎么把这 BF 的跟其他点的距离算出来呢？因为我们没有办法真的算嘛，对不对？所以我们就拿旧的表里面，我们现在算这个是 A 跟 BF 的距离嘛。那我们没有办法算 A 跟 BF 的距离，我们就回去偷看 A 跟 B 的距离，还有 A 跟 F 的距离，分别是18跟19。那不如就随便做个平均吧，所以18跟19平均就18.5，所以那一格啊就随便的填，就是平均填18.5。Okay, let's take a look at this the blue one, this one. I would like to know the distance between D and BF. So similarly, okay, go to the original table to find the distance between B and D and F and D, which is 18 and 17. So on the average, the distance is 70, 50. So we simply just average the distance in the original distance matrix, distance table, to the new table. So after we fill in all of the cells, then this run is done. Okay, we have a new cluster which is B and F. Their distance is 0.5. And we have a new matrix right here. So next, we can go to the next row. And this new matrix, which is the smallest one, is right here. A and D, the distance is 8. Okay, so we put A and D together and draw this height. Okay, that is 4, so we add them, the total height is 8. Okay, and we put it next to our cluster B and F. That is. So next step is still the same. We try to remove A and D, which is right here, and create a new data point called AD. So the next, we create a new data point called AD, and we have a new column AD and new row AD. So we have to fill in all those data distance by using the old. It's right here. By using the old distance matrix. So it's quite simple, right? Right here. For example, this blue one. I would like to know the distance between C and AD, and quite easily, okay, to find the distance of CA and CD, right, which is 27 and 26. Now we write the average distance right here. The most important things might be this one, the red one. Okay, it's right here. I like to figure out the distance between the new BA and the AD, which is I would like to know the distance of the new AD point between the AD point and the BF point, which is the previous cluster, newly created cluster BF. Right? So how do we do this? We go to the original Confusion matrix table and we calculate, okay? Since it is between AD and BF, so we find out AB, AF, BD, DF, and we simply just do the math to calculate the average. Okay, the average is right here, so we simply just put 18 in this cell. Okay, so that in this case, we know how to build this distance matrix, and so on and so forth. Okay, for example, find the smallest distance in the new distance matrix, which is BFNG, which is 12.5. And then we remove it and create a new column, a new row, which is BFG, and recalculate the distance by using the old distance matrix. Okay, and we still do the math. Okay, the average distance to calculate the distance between BFG and AD. Okay, at this moment, okay, we combine BF and G. So right here, we put G right here, and we connect it. Okay, the distance is 16.5, right? So 16.5 is right here, and BF is right here, G is right here, and so on, so forth, so on, so forth. And finally, we can combine this table all the way to the end. It's right here, something like this one. We can gradually combine 2 points, no matter it is the origin point, A, B, C, D, F, G, or it is a cluster, intermediate cluster. We can combine them one by one, one by one, one by one. And here is the answer. BF will be combined firstly, and then AD and BFG, and then AD and BFG, and then C, and then E. So we can make a tree. So basically, UPGMA is a clustering algorithm, which shows you how those data points are related. Okay? Okay, then that's all. Okay? Then that's all. So basically, you can apply this algorithm. So basically, you can apply this algorithm in all kinds of data like this. The data has no target, but it has several different features, and you can use these features, and you will predefine distance function to make a distance matrix. Okay. Let's stop here, and we will teach you how to apply UPGMA in Orange in the next hour. Okay, we stop right here.